Welcome, ladies and gentlemen, to this video lecture. Okay, so now we move on to a new section on the integration of trigonometric functions. So for example, what we want to do is we want to be able to integrate or we want to be able to evaluate integrals like the following one. So cosine cubed sine x sine to the 6x dx, and you could give it a try, but it might not work. You see, since we've got the product of two functions here, you could try using integration by parts, but you might get stuck somewhere. So we need a different technique to be able to evaluate this integral. Okay, now remember, integration by parts was related to the product rule for differentiation. So integration by parts was essentially doing the product rule for differentiation in reverse. There's another rule called the chain rule, if you remember, and this will help us in evaluating integrals like this one. So let us think about the chain rule. So let's say we've got functions from R to R, differentiable. And if we consider, I'm going to write it this way, g applied to f of x. And if we take the derivative ddx of this expression, what do we get? Then, of course, by the chain rule, we get the derivative of g applied to f of x multiplied with the derivative of x. So this idea is quite helpful. So when we now integrate both sides, we see that if we have an integral that looks as follows, so a derivative of some function applied to some other function, if we end up with an expression like this, then by the fundamental theorem of calculus, which we will come to, we have that this integral is equal to g applied to f of x. Okay, so the idea here is, if in any situation where we have an integral of this form, the derivative of some function applied to some other function multiplied with the derivative of this inner function, then we can use the fundamental theorem of calculus to evaluate this integral. And it will happen very often that this g prime will be a polynomial or a monomial. So for example, if we have something like this, if we have f of x to the n multiplied with the derivative of f, then this is, of course, then now we treat this part as a polynomial, f of x to the power n plus 1 over n plus 1 plus a constant. And you see, if you take now the derivative of this expression using the chain rule, you get exactly that expression. Okay, so this is the idea behind the following examples that we will do involving trigonometric integrals. Okay, I will see you in the next one where we will do some examples.